is right on the nose for the layout line that we had, if you can see that. This is not going to be a very good video, so I may have to redo this again. Okay, now if we were off, we'd see it. If it was off any amount, we'd see it. We know we're right on our dimension that we got to be. I'm going to lower this table here because we got some long tools that we're going to be putting in this chuck here. So I'm going to drop the table down. Here's I want to get this over here. Here's a crank on the front of the table. It drops everything down because we got some long tools that we've got to run in there to do our holes. That might suffice, but maybe not. I'm going to put this back where it was. I've got this camera attached to a nice big block here that I'm able to move around here a little bit. I apologize if it's not a good video here, but you see what the point is, that I've got all these holes and layout lines and everything done. I'm going to put this in the other way. I didn't like the quality of the hole that I got, so I'm going to spot this a little bit different. Okay, now, like I said, every hole is 1 inch apart. So we got our first hole at 1 inch. It's right on the layout lines. It's dead center in those 2 coordinates there. I'm going to drill it a little bit better. That'll give our drilling tools a better spot to start. Okay, I'm going to move another 1 inch. That'll be 2 inches where we go to. I just need a little starting spot for the drill. 2, 4, 6, 8, 10. Most tables on milling machines move 200 thousandths for every time you turn the handle. Okay, 200 thousandths. So you might be hearing me counting 2, 4, 6, 8, 10. So I'm at 3 inches. 2, 4, 6, 8, 10. Go fast. Come back right at 4 inches exactly. 4.000. Getting our starting spot marked here. 2, 4, 6, 8, and this is 5 inches where this one's going to be. I don't know if you can see how I'm moving the handle, but I always keep the play on the handle going clockwise on this end. If you have a manual machine and it doesn't have a CNC control on it, you've got a big long screw and a bronze nut in there. And if that's worn out, you're going to have some slop in the screw, so your table may not move accurately. The digital readout that's on there will tell you where you're at. You don't have to worry about that. But if you have an older machine that does not have a readout on it, always keep the play of the handle going clockwise from whichever end you're working on. This machine's only got a handle on one end. Older machines or other machines, non-CNC, have handles on both ends. So depending on where you're at, always go to the same rotation for your handle, so all the play in the screw is the same. I've been kind of talking here, but I didn't go down the list by steps here. Our first step was getting the sketch in the print and having some safety glasses on. That's a critical thing. The second step is selecting the material, which I've already pulled that out. Third step is how you saw and cut your raw material to length. The fourth step is preparing your milling machine. We look to see that the vise was straight on the table, because the table has a x-axis and a y-axis, and they are 90 degrees to each other. There's a few things that you have to trust on the machine itself. That is that the axes are 90 degrees apart, not 89.5 or 90.5. They got to be 90 degrees. So you can trust that that's what the case is. So you've got to prepare your milling machine, get your vise set on there, make sure it's straight. We machined the part to length. We're going to have topics on all these things here. Machine to part to length, I told you about conventional cutting and climb cutting and measuring the length. Believe me, we're going to have a lot of information to go over on measuring. That's going to be a key thing. We laid out the workpiece. I showed you the lines there. Hopefully you could see it. And when we picked up and located our part, that's the 7th step, locating our part in the machine so we can do our work. We know these holes are all going to be straight in line because we are all, the Y on all these things is at 500 thousandths, so they're all right in the location. So we've got different holes that we've located. And we've located the block in the machine properly. We spot drilled all the holes. Now we're going to put the various holes in there. So the farthest hole out here that you can see is going to be a 27/64 hole, because we're doing a 1/2 inch thread. Oops, sorry, I got my thumb in the way there. So I've got a drill index here. This is called the drill index. It's got all the different size drills in it, letters and numbers and fraction drills. Here's even a drill and tap index. It's got the tap drill size for the correct tap. This one's missing the right one for the 1/2 inch thread. So we're going to get the 27/64 drill out because we're putting a 1/2 inch thread in our block. And here's a 1/2-13 tap. If you look on the print here, you'll see that our last hole is a drill and tap 1/2-13. So we're going to drill and tap that hole. Let me turn the camera back over here. So we've already spotted our hole there. So we're going to put our drill in there. That's a 27/64 drill. That's the size drill that you use for a 1/2-13 tap. Again, I've got a decimal equivalent chart that I've used my entire working career. It's by Starrett Company. I'm not promoting or getting anything out of Starrett for using their card, but it's one I'm familiar with. There's many companies that make decimal equivalent cards like this, and it tells you all the sizes of drills to use for different threads that you might cut. It tells you what a 1/32 hole is in fractions and decimal. It's a 32nd happens to be 0.031, 31 thousandths of an inch in diameter. So it's got all that information on there. On this side it goes up to a 5/8 18 tap. The other side it goes on bigger. The other side it goes on bigger, 3/4 10. It goes all the way up to 1.5" 12 thread. 1.5" 12, that means that the outside of the screw that goes in there is 1.5" diameter, and it has 12 threads per inch. So that's what this chart shows you. There's a multitude of tap sizes on there. And this chart also happens to have all the metric sizes. You'll see a lot of metric sized holes that you've got to put in. And down here on the bottom it even tells you what size drill to use for drilling for pipe threads. So this is a handy little chart. If you write the Starrett Company, they'll probably send you 6 of them if you want. Or you can go to FabTech, the trade show in Chicago, and get these kind of charts from many different suppliers over there. Starrett have a booth there. Another one is Mitutoyo, Fowler. There's loads of tooling companies, and they have things like that they'll give to you. Well worth the trip to go to the show, like I had mentioned. Okay, so we've got the drill in there for our tap size, which is 1/2-13. So I'm going to turn this thing on here, and I'm going to slow the spindle down a little bit. That's a little bit bigger drill. And I'm going to come down and I'm going to drill that hole. Now, there's a little bit to be said for how fast the drill turns. I also use a little coolant. Let me grab that. I dropped my print there before, so I'm going to set that back up there. Okay, this is a water-soluble oil that assists in drilling holes. It's not an oil as far as lubricating goes. It helps cool the drill and helps the drill cut better. You can see the chips are coming out of there real nice. Just pour a little bit in there. And we can drill all the way through this thing. We don't have to worry about hitting our parallels underneath there because they're far enough apart where the drill won't hit them when it goes through. Here we go through right now. There we are. We got our first hole drilled. That's you just saw what I did there. I hit that thing in reverse real quick. These machines all run on three-phase electricity, and to forward and reverse the spindle doesn't hurt a thing. You know, you can't back out your car out of your garage and drop it into drive without fear of dropping your transmission. On these three-phase motors, that's what you are expected to be doing that, because when you tap your hole with the tap here, I don't know if you're not familiar with what the tap looks like. It's got a bunch of teeth on it, and these are, if you measure over these, it's a 1/2 inch diameter, and there's 13 little threads per inch that this thing will cut for a 1/2-13 screw. So we're going to tap that hole right now, since we're right on that location. We're going to be changing drills as we go down the line here anyhow, because each hole has its own size. And so we're going to go, I'm looking at the print, we got the hole in the right spot there, that's good. It's always a good thing. We're going to slow this thing down. This machine has a back gear, like I said, so I'm going to kick it into back gear. And now I'm going to turn the spindle on the same way. It goes backwards. We need to go, so looking down at the tap here, it goes clockwise. And you can see, I didn't change anything, but look at how slow it's turning compared to, I need some tapping fluid here. Bear with me 1 second. This is a different kind of a fluid that's used to help cut the threads. And you can see that thing goes right through there. It's spinning in the chuck because it's taking some torque to cut that thread. I tighten the chuck up a little bit. This is a trick you're going to learn from a guy that's been doing this manually. You know, a lot of people, they'll take that block out of there and they'll go try to use a tap handle and tap it by hand. That's a waste of time. If you've got a machine that's got a three-phase motor on it with a reverse switch, you can run this thing down through there. Now with that parallel underneath there, you can look and see, is the tap all the way through? Not quite yet, so we'll go a little farther. Now it's going free. So I'm going to reverse it, and it's basically unscrewing that tap right out of the hole. Now when you get up to the top where it's coming out, you want to keep the same pressure on the handle of the mill to get that thread, to keep from stripping out the thread. Okay? So, hole 1 is completed. That's probably one of the two most time-consuming ones. So we're done with that one. So I'm going to put all my finished tools over here. Our next hole that we've got to do going backwards is a 13/32 hole. So let me find a 13/32 drill. Right here. Put that in here. This is probably over the 15-minute limit for this video, but that's all right. We're in business here. Okay, I kicked this back into high speed. You can see how fast it's going there. Now I've got to move our machine over 1 inch, so it's going to go, it's at 5 inches right now, it's going to go down to 4 inches. 2, 4, 6, 8, 10. I went a little bit past it, but I want to go past it and bring my play of my screw going clockwise again from where I'm standing. That's a habit I've always had, and you need to keep those things consistently going that way. Okay, we're going to be going through this. This can turn a little bit faster than the other one. The smaller the drill, the faster the RPM relative to previous ones that we did. We want to give the chips a chance to clear out. We're going to squirt our coolant in there. It's a water-soluble oil. It's biodegradable.